we are moving on to part 2. So we have 3.7, part 2. And we are doing absolute value. Inequalities. All right. There we go. Absolute value inequalities. So first we're going to start with the steps. Very similar to yesterday's. Step number 1, isolate the absolute value. Step number 2, once you've isolated the absolute value, you set inside to the positive and flip the inequality sign and set to the negative. Step 3, solve both. Again, we talked about this yesterday. Anytime you have an absolute value, you're going to have 2, no matter what. Step 4, graph. Step 5, write the interval notation. I'm going to give you a little hint right here, a little star hint. If your sign is less than or equal to, it is going to be an AND problem, which means it is going to sandwich together. If your sign is greater than or equal to, it is an OR problem. So your answers are going to go in opposite directions. Okay. All right, so here is, yes. I forgot to put it straight on the limit. No way. Okay. Here is what we're going to be doing today. Let's say we have the absolute value of x is less than or equal to 4. It's already isolated. Okay. So we're going to take what's inside the absolute value, we're going to bring it over to the right. So we have x, and we keep everything the same. The second one we're going to bring over to the left-hand side. We're going to take the x, flip our sign, and make it negative. So now you'll see they're both pointing at each other. This is an AND problem. If we were to put this on a number line at -4, it would be a closed dot and it would go to the right. At +4, it would be a closed dot and go to the left. The interval notation would be a bracket, -4 to 4 with a bracket. All right. So everything we're going to do today, don't give me that look, Cooper. It's going to be fine. Okay? Everything we're going to do today. The first one we bring right over here. Write it all down. The second one we bring over here. Write the inside down. Flip the sign and make it negative. Well, then we got to solve everything. This one's solved already. But so here we go to example. It's going to be okay. Here we go to example number 1. All right? It's not. Follow the steps. It'll be fine. Example number 1. We have the absolute value of x plus 4 is greater than 10. Is the absolute value all by itself? Okay, so first we're going to take this inside right over here. We're going to say x plus 4. We keep everything the same. The second one we write down, we're going to bring right over here to the left. I'm going to say x plus 4. We flip the sign and make it negative.
Wow.
Yes.
I'm guessing, like, especially when when after you isolate the, absolute value, there's no way it'll be negative, so when you switch it, it doesn't go back to positive, right?
Correct. Okay, now we're going to solve both of them. First one, we're going to subtract 4 from both sides. So I have x is less than negative 16. Here I subtract 4 from both sides. Oh, negative 14. You know, I'm tired too, you guys. I'm just making sure you're paying attention.
I saw it right here.
She was checking on it.
Okay, so, you guys, so we have x is greater than 6 on this side. What kind of problem do we have here? An OR problem, right? So, on my number line at negative 14, I have an open dot and it goes to the left. At 6, I have an open dot and it goes to the right. Again, I want to remind you the interval notation for an OR starts at the arrow of negative infinity, goes to negative 14. In this case, it's an open dot, so it's a parenthesis. Where that OR space is, we get a U, parenthesis, 6 to positive infinity.
Basically, what we did yesterday and then flip them.
Flip a sign, yep.
And then make it negative.
Flip it, make it negative, yep.
That's actually not that bad.
Okay, so let's try another one. Try another one, example number 2. Example number 2, let's go with, guys. Okay, let's say I have 4, absolute value of 2x plus 6 is less than 24. All right, is my absolute value isolated yet? What do we have to do? Good, so we're going to divide both sides by 4. So we have the absolute value of 2x plus 6 is less than 6. First one I'm going to bring right over here. I have 2x plus 6 is less than 6. Looks just like it without the absolute values. The second one, I'm going to bring over on this side. I have 2x plus 6. I flip the sign and make it negative. All right, so we're going to start by solving over here. First, I subtract 6 from both sides. So I have 2x is greater than negative 12. Divide both sides by 2. And x is greater than negative 6. Let's go to this one. Subtract 6 from both sides. We get 2x is less than 0. Divide both sides by 2. And x is less than 0. On my number line, at negative 6, do I have an open or closed dot? Open, and it goes to the right. At 0, do I have an open or closed dot? And it goes to the left. So you can see all my interval is sandwiched between 2 endpoints. This is an AND problem. It goes from negative 6 to 0. All right, you guys, give me questions before I keep going. Yeah, go ahead. Well, we're going to talk about the special cases tomorrow. Okay, so we'll focus on this first. No special cases today. Okay? Yeah. So, and then we'll talk about those tomorrow. We're going to do a couple more. Yes. 10. It'll be okay. A whole 10. Whew. All right, example number 3. Example number 3. Enough. All right, let's say I have 2 times the absolute value of negative 3p plus 3 minus 9 is less than or equal to 21. Ashton, first step, go. I agree with Clara. Right, we have to isolate that absolute value first. So we have 2 times the absolute value of negative 3p plus 3 is less than or equal to 30. Now what? Now we can divide by 2. I totally agree. So we're going to divide both sides by 2. I have the absolute value of negative 3p plus 3 is less than or equal to 15. We take what's inside the absolute value now that it's isolated. We're going to come over here. We have negative 3p plus 3 is less than or equal to 15. The other one is negative 3p plus 3 is greater than or equal to negative 15. Now the reason I put the first one on the right and the second one on the left, why do I do that? Yeah, the negative should be on this side, right? That's why I've been doing it that way, so you guys can see it when we go to put it on the number line. Okay, first we're going to subtract 3 from both sides. So I have negative 3p is greater than or equal to negative 18. Here I oops, I got to finish this one. Divide both sides by negative 3. What happens to my inequality sign? It flips. Positive 6. Over here, I'm going to subtract 3 from both sides. I get negative 3p is less than or equal to 12. I haven't divided yet. I flipped. Oh, I didn't flip it. My bad. I didn't flip it. Thank you. See? All right, it flips. You're right. So when I divide by a negative 3, what happens over here? It flips. So I get p is greater than or equal to negative 4. What do you notice about our 2 inequality sign, or 2 inequalities this time? They go like that, but look at the numbers. Right? Yeah, they got to swap places. Thank you. So technically, we have p is less than or equal to 6. So if I put 6 here, it actually goes this direction, and negative 4 is over here, and it goes this direction. So it still is an and problem. It's just when we divide it by a negative, we flip them around, right? All right, so we have a bracket, negative 4 to 6 with a bracket. You guys. Hey, that's enough. Enough. All right, one last example, and I'll get to your worksheet. Example number 4. All right, now again, you guys, I need to see the steps so I know what's going on, right? I need to see where things are coming from. Yes, Cooper.
Still a little confused about the last one, like how was the and?
Well, it started off as an and. Look at it. Let me go back. Okay. So right here, first of all, if you look at my little note underneath our steps, if it's a less than, it's going to be an and problem, right? Okay. When we split it up into 2, it still looks like an and problem. Okay, but when we got down here, see if I can just move it a little bit. Yeah, when we got down here, the sign flipped, but what happened is the inequalities are on the wrong side, right? So not only do we have to flip the sign when we divide it, but that means this inequality should have been over here, was all it was. Okay? Does that explain it better? Because it's still an and problem. It started as an and problem, it was an and problem in the middle, and it finished as an and problem. What you see on that inequality sign when it starts is going to tell you. Okay? What? What is what? Oh, it's yeah. Thank you. All right, here's the last one today. Let's go with 4 plus 2 times the absolute value of 6x minus 3. And let's go minus 4. Minus 4. I know it. Is greater than
12.
Sure, we can go 12.
Or you could
All right, so first of all, you can look at it right now and know what it is, right? What kind of problem, just a minute. What kind of problem do we have here looking at that inequality sign? It's an OR problem. Okay, so when we're done, it should still be an OR problem going opposite directions, right? So first, we have to get rid of the 4 in front. How do we do that? Subtract 4 from both sides. So, we have 2 times the absolute value of 6x minus 4 is greater than 8. Divide by 2, I agree. We're going to divide both sides by 2. So I have the absolute value of 6x minus 4 is greater than 4. Now that I've isolated, we can split it into 2. Ashton, what's my first one?
6x minus 4 is greater than negative 4. Alright. Okay, I guess it's positive 4.
Okay, what's my other one?
And then I just 6x minus 4 is greater than negative 4.
You got to flip the sign, less than negative 4. Don't forget to flip the sign. I know you did. All right, now we're going to solve both of them, starting with the left-hand side. I'm going to add 4 to both sides. I get 6x is less than 0. Divide both sides by 6, and x is less than 0. Over here, I'm going to add 4 to both sides. I get 6x is greater than 8. Divide both sides by 6, and x is greater than 4/3. All right, on my number line, I want to talk about this, right? Because I'm providing you with a number line today. Here's 0, 1, 2, 3, 4, 5. First of all, x is less than 0 is an open dot, and it goes which way? Goes to the left. Okay, how do I know where to put 4/3 on the graph?
you divide it.
Make it a decimal, and we get 1.3 repeating. So that means I go a little bit more than 1 and put my open dot there. And which way does this one go? Goes to the right. Okay, so this is negative infinity to 0, a U for the space, 4/3 to infinity. Any questions?
No, ma'am.
No questions at all? You're all good?